Hi, I'm Liz McGinn. I am Senseye's new demand generation lead here in America, and I'm joined today with Boris.
Hi, Liz. Good to be here.
Nice to see you. Today we're going to talk about industrial AI and what does that mean to us. Boris, what is industrial AI?
Yeah, well, first of all, industrial AI is nothing more or less than the application of AI in an industrial context, right? For industrial applications, whether in discrete manufacturing or in the process industries. And of course, industrial environments just bring their very specific flavors and requirements. So, in terms of the degree of quality that is needed, the degree of robustness and reliability that is needed, all of that certainly is different in an industrial environment. So industrial AI must reflect that in one way or the other. The other topic that I find quite interesting is industrial AI is also a bit of a challenge from a business case perspective. You have certain areas in other industries, right? You have certain use case types in other industries that are much easier to scale than what we find in industry. So there is a specific challenge to make industrial AI, to make AI work in industry. Um, and that isn't just a technology issue, that is also an issue of use case scaling. To give you an example, if you use AI maybe in stock trading, then a very incremental improvement in an algorithm can make a huge financial contribution. So if you have, say, a team of 20 data scientists, like working day and night on this little increment, the return on invest could be very, very rewarding, right? Same thing is if you look at AI to optimize, say, Google ad placements, right? You can have a very small team working in incremental steps, huge financial return. In industry, scaling and making also a commercial difference is a lot harder. So maybe it kind of belongs between the lines to the definition of industrial AI that we have to work and live and somehow work against all those challenges on the technical, but also on the commercial level.
Where do you see industrial AI working in the industries?
Industrial AI working in industries, well, we have different areas along, I would call it a simplified version of a value chain of our customers, right? It really starts at product design.
Hmm.
Because already at product design, when you start designing a product, you have to look into how do I produce it? Not only what features does it have, right? And how can I optimize maybe the quality of those product features by the use of AI for, say, simulation, yeah, product feature simulation. But it doesn't stop there. It actually proceeds to, hey, how can I produce this? What portions of the product should I source? What products, portions should I and components should I build myself? What are the production capabilities that I need to do so? And how can I simulate that maybe, right? Industrial AI has already a place, an important role in those early phases of a product life cycle. But then as we move into production, it has a great contribution to things like uh, equipment operating efficiency, right? Predictive maintenance, for example, looking at Senseye. Also predictive quality. Can we already predict how good a certain batch in process industries will be, right? If I start brewing beer, can I already make a prediction whether in 2 or 3 days from now it's going to be within my quality boundaries so I can sell it? Or can I predict very early in the process that something is going wrong and I can actually stop the process and restart it and save a lot of time by being able to do that with the use of predictive quality? Certainly, quality inspection, including everything that is connected to machine vision, right? For quality inspection is a big area of the use of industrial AI. And last but not least, robotics. So for sure, the way how robots behave or misbehave in certain areas, and also how long it takes to train them to do what they should do. Industrial AI plays a great role in that area.
So really, it kind of goes into all parts of it, and it's important for us to be able to learn how these algorithms to learn what we're doing in our factories to help us as humans, have a more efficient process.
Absolutely, and this statement is very true in each step, right? If we look at the product life cycle, if we look at product design, if we look at production engineering, as we call it, right? So preparing a production to produce a product in operations, and even at later stages in the service phase, life cycle phase of a product. In each of those phases, industrial AI can have a major contribution. But now, what comes on top of it is, if you look at the new developments leveraging generative AI and like these transformer models, right? And the fact that they can generate code that that uses different APIs from different applications and can bind those different applications to each other. I would call it glue code, right? The glue code between applications, and all of these applications form company-specific workflows, right? And now you can use generative AI even to automate creating those workflows, and then you can use those pieces of glue code even to link applications to each other for simulation. And this opens up a completely new dimension of digital threads, the creation of digital threads, and the combination of those digital threads with a simulation. So when you start developing a product, you could talk to different applications to see, this product variant, can I produce it? How efficiently can I produce it? How long will it take to produce it? Should I choose another product variant, not this one, but another one, because I can produce it more efficiently, faster, consuming less energy, consuming less material. And I can not only simulate the product and its features, I can simulate it through its life cycle in hundreds, potentially thousands of variants, and look at the machines that it is using, and so on and so forth. There's a universe of new opportunities if we look into the potential of AI, and in that case, particularly generative AI.
Do you see some hesitation from companies like trying to go into AI?
Yeah, is several, of course. First of all, AI hasn't been industrial yet, industrial grade, I call it, right? So, if you have a certain function in your production, that function must be robust and reliable. It must have the what we call 5 nines of reliability, right? And 99.999%. We don't want to put mission critical processes like production. We don't like to put that on something that is as fragile as AI is in many areas. So first of all, there is this challenge of making AI industrial grade and increase the degree of autonomy, because many shop floor applications, many industrial applications today have still the human in the loop. Yeah, we have a great suggestion, but by AI, but don't rely on it. You need the human in the loop, because we are not liable. We can't guarantee for what the AI produces, which is in the end of the day something that we would like to change. We would like to create AI that is robust enough so everyone of us can look at different things to work on, not necessarily the stuff that can be, is repetitive and should be automated. So that's one challenge that we have to overcome in several aspects of the use of AI. The other one is, if we look into co-pilots working with language models and generative AI and supporting engineers, product designers and engineers, of course, there's the concern of how much data do I reveal? If you have a co-creation partner such as Siemens, and we are building industrial co-pilots for our customers and with our customers, how much of my IP do I have to hand over to a partner such as us? And how much of that IP is commodity IP versus how much of that IP is differentiating IP, core IP that I don't really want to see any other company having access to via directly or indirectly via a network, via a model, a generative AI model. So companies in the future who really would like to leverage AI and generative AI for their competitive advantage need to go through that cumbersome steps to maturing AI to become industrial grade on one side. And we are ready to help with that, of course. And also to the cumbersome work of classifying your data, your know-how, your knowledge pools, and saying, well, this is my own stuff, and I really cannot compromise. But this is a data pool, this is a knowledge set that is fine with me to share, because I know AI will be improving by me sharing those portions of data. And when it comes to addressing the skill gap that we are all facing in the automation area, for example, I need to do my contribution so the AI becomes better, good enough to also work in my environment and help me with addressing the skill gap challenges of the future.
So you said that people work with AI to make it better. I know that we do that over here at Senseye. Obviously, our maintenance works with the our AI to help improve it, and so we know more of what's going on. And that's about the sharing data thing, which also so we get into that as well. How do you see people working with AI more in other than just like the designs?
So predictive maintenance is one of those examples where, as a matter of fact, it sounds pretty easy, and then it can become incredibly complex, right? I recall a use case from our friends of Siemens Energy, and they are producing turbines, and they are selling turbines to, for example, companies that have a process plant, and the waste heat that comes out of that process that they are running is actually used with a turbine to then be converted into power. And long story short, this process plant that they are operating, that can only be switched off for a maintenance window once a year, right? And it's not us asking for the maintenance window or our friends from Siemens Energy. They cannot raise their hand and say, oh, we need a maintenance window for the turbine. It doesn't work that way. It's the operator of that plant who says, oh, there are these 10 days each year, and this is when you can replace parts. So we and our colleagues from Siemens Energy had to adjust all the prediction of which part needs to be replaced by when. What is the expected useful remaining time of a part, right? To make sure that in those 10 days, everything could be replaced that needs to be in an accurate state, spotless state, to run for the next year. And this is an example, right, where only AI and data analytics goes hand in hand now with a new business model, which is that turbine isn't sold as a piece. There is a guaranteed output behind that turbine. And not only that there is a guaranteed output behind that turbine, Siemens Energy onboards all the liabilities and responsibilities for part replacements within that given maintenance window. And you can imagine that the algorithms behind that type of predictive maintenance are absolutely instrumental to run such a business model. You cannot do these types of deals if you don't master predictive maintenance. And wherever you look into industries, if you really look deeper, you find these very amazing, interesting types of business cases enabling new business models, assuming that someone masters the algorithms behind it properly. And this is the degree of excellence that you see then, right? If someone takes AI, makes it industrial grade, and can provide these types of value creation business models towards their customers.